well. So with that, let's get started with the workshop itself. And the structure, what I had in mind is that this is going to be a hands-on workshop. There'll be very little slides and we'll actually be writing code and seeing how visual testing really works and can add value for us. Ask questions whenever and wherever you have. If you think I'm going too fast, please do interrupt and ask me to slow down or repeat. We want to make sure this is valuable to you. Also, the code that I will be showing is for using Selenium Java, but you can use any other programming language as well. That does not matter. It is going to be very similar, and I'll be able to guide you in most cases along the way how to use that as well. We have a really packed agenda. There is a lot of things that I want you to experience on your own. And let's see how much we can really get going in that regards. OK, I will keep sharing with you some sample code on chat, which you can use in your framework and get started much more quickly as well. So that's what we'll do. So let's see how much of these 9 items we can really achieve today. OK, a very quick refresher of how Applitools really works is if you take a simple example of a login page, if you have to write a Selenium script to do all the validations for this login page, when you do not enter credentials, what is the type of error messages and behavior you should see, you end up writing a lot of code in your script. There is one navigation, one action, and then there is a lot of validation code that you write. And this takes a long time to implement. However, if you use Applitools Visual AI, all the validation code can be replaced with a single line to Applitools, and Applitools will take care of the functional and visual validation for you. With this approach, what you see is in a typical traditional automation approach, a lot of defects actually can escape out to the higher environment because your traditional functional automation cannot really take care of these types of validations. For example, a missing image or overlapping content or color changes. In some cases, maybe you can write validation code for it, but there is a lot of effort you need to put in for some very basic validations. Instead, with that single line of code that you use with Applitools, Applitools will present to you all the differences that exist on the screen, and it will give you those, whether it is defects or new features that have been caught by the product. You will be able to get all of that automatically, and you can take quick decisions based on that. So instead of spending a lot of time, about maybe 2 hours to write a simple test and update that test based on new functionality or new validation errors that you have seen, you end up finding only about 40% of the defects, and there is a lot of false positives as well from your automation. Versus where you use Visual AI, you are getting the test implemented extremely quickly. The test is more robust and stable, and because you're using less locators, you are able to get a better confidence on your automation and less reliance on the actual DOM structure. You focus on the functionality and the visual aspects of your code, of your product, sorry. So hence, what we say is that you should be using visual assertions instead of functional assertions. So you will still end up using your same test automation tools for driving the browser under test or the native app under test to do what is required to be done. But all your validation will now be taken care of by Applitools. It will take care of the functional validations as well as the visual validations, and it makes your test more robust and stable as well. This part we have covered in the webinar, so I will not repeat this part again. But what is important to know, which we will be using today as well, is we'll be looking at not just the core AI algorithms that Applitools has, but we'll also be seeing how it fits in seamlessly with our automation and how we can really use this automation to scale our coverage from a single browser perspective, and also how can we scale it across multiple browsers to get that validation very, very quickly. And that's where we will talk about the ultra-fast grid, and we'll actually write a test that will allow us to experiment with the ultra-fast test cloud, where we will run the test on your machine using Selenium and any language that you want, or any other tool where we have a SDK, you could use that as well. And whenever we integrate Applitools with it, when you have specified the different browser and devices configuration, you will be able to see the test results from all the different browsers and devices automatically as part of a single test execution. So this will show you the power of scaling and quick feedback. Also, I'm very happy to let you know that if you are working on native apps, our ultra-fast grid is now available on iOS native apps as well for that platform. And the Android native app platform work is also ongoing, should be available very soon. So what this means is you will be able to scale your native app test automation as well very seamlessly using Applitools. Now, before we get started with our core hands-on activity, last set of things I wanted to bring to your notice is, where does visual testing really fit into your automation journey? You are aware of the test automation pyramid, where there are various different types of automated tests that can be implemented for your product, starting from bottom of the pyramid, that is unit tests. And as you move on top of the pyramid, it's component tests or API tests. There are contract tests, there are workflow tests and system tests as well. System tests are your typical UI end-to-end tests that are there. Now, wherever there is an aspect of visual component, that means if there's a UI component testing that you are doing, so this blue layer over here, second from bottom, there is some visual component possible over here, and that's where Applitools can fit very seamlessly as well. And of course, when you look at the UI test, the end-to-end test, what we also call as system tests or functional tests, visual testing fits in very seamlessly over there as well. So using visual testing is very easy, but using it correctly needs some thought process and understanding of what type of tests are important to be validated at a UI layer and how can visual testing help in that regards. Okay, so the test automation pyramid includes visual testing at two different levels, and that can give you a lot of value, increased coverage as part of your automation. Now, from an integration perspective itself, we know that there are a lot of different types of SDKs possible. And on the left, what you see are SDKs that Applitools has built and is maintaining. But there are a lot of tools that are out there in the market, functional testing tools, which have built integration with Applitools on their own because they see the value and the power of visual testing in combination with functional testing. So there are a lot of different ways how you could use Applitools in your automation journey. And of course, just integrating it with automation, functional automation is not sufficient. You want to see these results as part of your CI pipelines, and you could be using various different means how to run these tests as part of continuous integration. We have integration with all of those, the popular tools, and also the various different integrations with ALM tools as well as our DevOps, Jira, Slack, and so on. So there is a lot of collaboration that is possible with this particular approach. Okay, so with that, I'm actually going to stop with the slides and let's get started with our core hands-on activity. Before we start off, are there any questions that anyone has? Okay, I guess no questions. Has everyone been able to do the machine setup? Were you able to run the test code just to make sure everything is fine? Is there anyone who has? Okay, great. And has everyone also signed up for a free Applitools account? Have you received the API key? Great. So everyone has the API key as well. Alex is saying I could run it, but the test failed. Yes, that is fine. The test failing is not a problem. It still means your integration has gone through. It's working well. OK, so what we are now going to do is I'll quickly show you some code. I hope the font is visible. OK, so what we have in this code, and I will share this code on chat as well with you. In fact, let me do that first. OK. I will quickly zip up the whole folder and send that across. Unzip it and open it in your IDE of choice. In the meantime, I will quickly walk you through what we are going to be doing today. So what I have on screen over here is a simple Selenium test. And what this test does is it uses WebDriver Manager to first set up the Chrome driver, or the in this case, I'm running the test with Chrome. So WebDriver Manager automatically will get the corresponding Chrome driver required for the version of Chrome that I have on my machine, on my laptop. And once we get that, I'm setting it as a property. And we are using that Chrome driver to run our test. In this test, it's a very simple test where we just go to a particular website and we're going to do some action on it. OK, after the test completes, there is a teardown activity where we close the browser and the WebDriver that was created, the Chrome driver that was created for running this test. So this is a very simple test that we have, and that is what we will be running. OK, if I quickly run this test just to show what is going to happen. You see over here the browser has launched and it did one action and the test completed. OK, so the first thing that we want to do is take this sample test from the project that I have shared with you, set it up, rather open it in your IDE and run this test. There are some other files as well over there. We are not going to use those right now. We'll just run the plain SE test first. Can we quickly do that and let me know when you're done?
For me, it worked. I could run it and it passes.
Excellent. Excellent. We'll just give everyone else half a minute to catch up.
In the meanwhile, I have a short question for you, if that's
yes,
okay.
Please. Yes, please.
I wanted to ask before, but I had a problem with my microphone in the beginning. At the company where I'm working right now for a project, they're using 𝗶𝗀𝗃, or they bought 𝗶𝗃 together with BrowserStack. So my question is, what are the mainly differences or things that from your point of view is better or more efficient in Applitools?
Absolutely. So there are a lot of differences when it comes to that. So 𝗶𝗃 does pixel comparison for visual testing, and it allows a more, I think it's 1 pixel difference or some such mode. It's a tolerance limit essentially, but it's still pixel comparison. So the minute you have to do visual testing for pages or a product which has dynamic content, that is not going to work, right? Because when you do pixel comparison, even between browser versions, at times you might end up getting differences. So with dynamic content, that is just not possible. The second big difference is that is only for browsers, and that too for very few specific browsers. However, Applitools will work with browsers, mobile web browsers, native apps, desktop apps, PDF documents, images as well, right? So there's a lot of scope for validation depending on how your product is, what different platforms your product is available on. So these two will be the most important differences in my mind, right? Pixel comparison versus using AI to do the comparison. And as we'll see in the workshop, when you will start playing around with these algorithms as well, you will see the kind of value you are able to get with these algorithms. And second, if your product is available on multiple platforms, then the same tech stack can work across for all these platforms. You don't have to use different tools for them.
Okay, interesting. Well, I haven't used 𝗕𝗄𝘂 yet. I know they bought it and they recommended to use it, but I haven't had the time to experiment with it. But maybe I give Applitools a try even before 𝗕𝗄𝘂.
Absolutely.
I didn't know 𝗕𝗄𝘂 is only a pixel comparing, because that's exactly that's not what I need, of course, for our dynamic application.
Correct. Pixel comparison is going to be the big thing, right? And plus, when we see in the workshop later today, in a very short while for that matter, you will see that you need different types of algorithms on specific screens to get the best value of the validation, depending on context of your product, right? And Applitools provides you that flexibility programmatically as well as from the dashboard to fine tune your validations using different algorithms so that you can get the best value and the best, most accurate comparison. And then whatever differences are highlighted to you, that you can be sure that either that's a defect or your product has evolved, so you need to update the baseline, right? There's not going to be any false comparison that will happen with the kind of flexibility that you have. So we'll see that.
Pretty interesting. And I had a second question, if you still have the time for answering questions. I saw you had for running on multiple browsers. Applitools had an equivalent of browser stack. Did I understand that well?
It's a very different technology than browser stack or Sauce Labs. It's called the ultra-fast grid. And we will be doing this exercise as well, where you will see value, where you will see what kind of value you are able to get. So I will actually request you to hold on to that question till we get to that exercise. And then seeing by running the code, you will be able to understand how it works.
Okay.
Yeah. Okay, cool. So I hope everyone has been able to run that first test. That means we've got a basic Selenium test running now. And now if you take a look at the next test that is there, SE test with Applitools. If you just open that code, it's shared on my screen as well. There is some difference that is there. I'm going to compare this with split and move right. Okay, so now what I have on my screen is both these tests that we have. One is on the left hand side is the one with Applitools integrated. On the right hand side is the plain Selenium test. If you see what is happening, what are the differences, I have now added over here a before each annotation method. What that means is for every test that is going to run, this particular piece of code is going to run along with that. Now, why is that required? Because in my Selenium test, I was creating the browser driver in the test itself, in the test method itself. And that is not really the recommended practice, right? Why repeat the same code in each and every test? That's where it should be there in the before each method. So that this code has come into the before each method, but now we have added some additional setup code that is required for Applitools. Okay, So what we are saying is we are creating a new instance of the classic runner, that is Applitools classic runner. Using that runner, we are creating an Applitools eyes object. This Applitools eyes object we are going to configure in certain ways. Over here we are saying what is the default algorithm that I want to use for comparison. Do I want to use a full page screenshot? If I am taking a full page screenshot, what is the stitching mode that is required? Do I want to use CSS mode or do I want to use a scrolling mode? And we'll talk more about that later. I've also enabled verbose logging from Applitools side, which is a good thing to enable in the initial days when you are implementing the test. It will give you verbose logging, but it will be able to understand what is Applitools doing under the covers. And we are also setting a name of a batch, how we want the test to be collated. Once this is done, we are setting this configuration in Applitools, and then we are saying eyes.open. Eyes.open is a very important activity that is required for every test. It essentially tells Applitools that a new test execution is starting. And what type of test is this? It is taking the name of the application. The name of the application is demo app Selenium for Java Classic, whatever is the name of the application. The name of the test, in this case, I am using my username as a prefix and getting the test information, the name of the test method. That is my test name. I'm also telling Applitools what is the viewport size which I want to use when you start running this test. Typically what we do when we are running Selenium type tests is once the driver is created, we automatically or implicitly end up doing a browser.maximize, right? Maximize the browser window and then run the test. But products, web pages are responsive in nature. At different resolutions, the rendering is going to be different. So in order to get consistency, we tell Applitools what is that resolution that I want you to run at. And at that resolution, Applitools will resize the browser window and the test would run accordingly. We also pass the WebDriver instance to this eyes.open. And from this WebDriver instance, Applitools figures out which is the OS and the browser for which you are running this test. So these 5 parameters combined together, the browser OS, application name, test name, and the viewport size uniquely identifies when a screenshot is taken, which is the baseline that I want to get to compare for this particular screenshot. You change any one parameter over here, Applitools will try to find a different baseline based on these unique parameters again to make sure you're doing the correct comparison, apple to apple comparison. But now because this is all boilerplate code, right? You don't need to change this every time. That's why creation of the driver and setting up of the Applitools configuration is best done in the before each method. Now, after the before method runs, that means my driver is created and I have instantiated Applitools, then I'm going to start running my test. In this test, it's a very simple test where we are saying I just navigate to a particular site. Over here, I'm doing different ways. I'm going to do a visual validation. And we'll talk about these methods soon after you are able to run these tests as well. We do some additional navigation and actions. And then we are going to do some more visual validations. And then my test completes. Because that's all was there in this particular method. After the test completes, we are now going to go to the after method. In the after method is typically where we say driver.quit. That means I'm going to close the browser and the WebDriver instance. But over here, I'm also telling Applitools this particular test method has now completed. And let's get the results of this test execution. And in this case, we are just printing it out over here to the console. OK, so very simple test. Identical test as the plain Selenium test. The The only difference is we have added boilerplate code for setting up and tearing down Applitools object as well. And whenever we want to do any visual validation, we are just going to add methods like eyes.checkWindow. Okay, so what I want you to do is I want you to run this particular test, SE test with Applitools. Okay, just run this test and tell me what you see.
I receive an error that my API key is missing, so I suppose I still have to add it somewhere.
Excellent, excellent. So default, so you would see in my code over here as well, test is still running, but in my code, I do not have the API key specified anywhere. So by default, what Applitools does is it looks for an environment variable called Applitools_API_key on uppercase, and it is going to try and retrieve it from there, because you should not be having any keys mentioned directly in code. But in this case, because you do not have it set as an environment variable, you have received it in an email, right? So what you would do is you have to copy that API key and you would say config.set API key and paste the API key that you have got in email over here and then rerun the test. Okay, so config.set API key. I'm just putting this in chat. In my case, this is equivalent to string, not string, sorry, system.getEnv. Get API key. Because I have it set as an environment variable, it is automatically getting that. As the test is running, you would see there's a lot of console information that is there. Whatever calls are being made from Applitools, you'll be able to see that information. In the initial days, it is good to have this to make sure your setup is done correctly. And if there's a problem, that's what would be required to be shared with the Applitools support team. Okay, is everyone done with their execution? I see Alex and Bart are saying yes. Anyone still running the test or has any difficulty running the test?
It gives me a still element exception though. I don't know if that's expected.
There should be no stale element exception.
Yeah, I have the same. Yeah.
Yeah, that should be fine.
Okay. Yeah.
And we just replace this line over here, that should take care of it. Okay, so what you also see in the end, right? Just before that exception that you would have seen, there is this in the console, the results summary. In the results summary, you have got test results container, And inside that result, for each test, you will see the results. We just ran one test. So for this test, there were 3 steps. The name of the test, how many matches were there, how many were mismatches, and there is a link to the dashboard. So you can copy that link, copy that URL, and open it in a browser. You will be able to see your test execution over here. Is everyone able to get to the dashboard and see the results? Is this test still running for everyone, or you're done with the execution? Okay, Bart is saying yes. I've just rerun the test by making that one change to get rid of the stale element exception. Actually, this is going to give a different exception. Element not found most likely. Let's see. Okay. So is everyone able to log into the dashboard? This is no such element. Yeah. This is actually the correct behavior what we are seeing. Okay, so now what happens is when you ran the test, you would typically you might be seeing it as passed or as unresolved over here. But what happens is, just to understand what really happened as part of the test execution, when 𝗏𝑠.open was running, in fact, I'm going to just re-trigger the test to show what you see in the dashboard. As soon as 𝗏𝑠.open is called, now my test has started running. The browser just launched. I see the test is running. That means Applitools has got a notification that a new test has started running. Okay. Inside it, there is this one particular test that is running. It's running on Mac with Chrome 94. This is the name of my test and the viewport size. The app name is hidden right now because I had not selected it. This is the name of the application that I had set in the test execution. Okay. So these 5 parameters combined together is saying when Applitools start getting information for this test, based on these 5 parameters, it will check, is there a baseline for this test combination already existing with me? So the first time when I ran it, it was new because there was nothing corresponding to this test available with me. Every subsequent run, I start seeing it as either passed or unresolved when there is a difference that is found. Okay. Every call to 𝗏𝑠.check. Now let's talk about what those lines of code are doing for you. The first one, I'm saying I want to check the full window with the name login window. And that's what we see in the dashboard. This is the name login window. This is a full window check that I am doing. I could also do this in a different way. I could say this is region, and by over here, in fact, let me do it this way. Dot region login element with name. I'll quickly run this one again. So you're giving it a meaningful name. What is the name of the screenshot? Because when you look at the dashboard, you will be able to make a sense of a logical sequence of your execution as well to understand what the test was really doing. There's context with this app window compared to the same window when it is going to run as part of another test. So the name is going to be important from that sense, but this is optional. If you don't provide a name, Applitools will not put any name over there. That's the only difference. But now these two methods, line 85 and 86, are really the same in this case because check window is the same as target.window.fully. However, line number 89 that I have is a different way to check that, do a visual validation. Instead of a window, I'm giving it a specific element that I want to compare. And this we will see. I think the test is completed. It's still running. You see over here, I just gave the login the login element as comparison. But I did not change any other parameter over here. So that's why it's doing a wrong comparison of the screen. My test implementation was not correct in this case. But I am now able to do comparison of specific elements as well. That element could have been this complete table for that matter, the recent transactions. I just want to do comparison of recent transactions. Nothing else on the page is as important to me. So you could choose selectively how that comparison should have happened. What you could have also done is dot match level dot strict. You could have also said, I want to do this comparison. In fact, we should do it over here with match level dot strict. And let's run this again. So you could have given a match level within the Fluent API, which overrides your default behavior that you have set in your configuration. The configuration, remember in the setup task you had set the default algorithm to be used is layout. If you have not specified a default algorithm, then strict algorithm will be used as the default algorithm. But you can override that in context of a test execution. So now with this particular approach, you would be able to say, I understand the context of my test. I understand the context of the page where this particular test is running. And now for this particular test, I want to use a different algorithm for the specific region. And I want to do the validation accordingly. In fact, if you see this, this is also a similar method, but you could have provided additional elements over here, and for each of those elements or regions, you could have used a different algorithm for validation. Now let's see the results of this test that we have run. We see the login window. This one was compared using strict. This one was compared using layout. And why the difference? Because I mentioned over here, my first comparison is going to be using strict. I'm overriding the default behavior. The second one, I did not provide an algorithm, so it is using the layout algorithm. And as we continue going forward, it is going to do the validations accordingly. It is now doing this comparison using strict. That's where the differences also show up. OK, with me so far about what these kind of APIs, we call them as fluent APIs in the Applitools terminology, because it gives you it's a fluent style of writing the APIs, and you can build using builder pattern. You can build specific types of validations that need to happen as part of that single UI validation that you are doing. So typically we would not need so many validations over here. There would just be specific ones that are required, one before entering credentials, one after clicking on the login button, and that probably takes care of our validations. So there's no other assertions required, because now at the end of the test, if you see this test has still failed. It is failing for two different reasons. One is, of course, there was some element which was incorrect in the test that I have provided. So that is a different problem. But then in my results itself, I'm able to see the results from Applitools that there are differences found and the test is getting failed because of that as well. So with this approach, you'll be able to run your test functionally and visually, do both these validations, whether you're running it on local machine or as part of your CI executions as well. And the test will fail for functional and or visual validations, depending on how you have implemented the test. Any questions so far?
I had a question over about that baseline picture. How is he getting that, or how does he decide which one is a baseline?
Sure. So this was, you see the status new over here, right? That means this was a new test that was created. The first time this test was run on Applitools, or again using Applitools. So using the 5 parameters that we have, the parameters are these, right? The name of the application, the OS, browser, test, and viewport size. A combination of these 5 parameters together is used by Applitools to figure out, does this test have an existing baseline? And if it doesn't, then by default, Applitools will create a new baseline for you automatically. You don't have to worry about it. Applitools will automatically create a baseline for you. Of course, this default behavior can be overridden. In your configuration, you could have said over here, config dot set save new test to false. In this particular, with this way, if a new test combination is running, Applitools will not automatically save it and pass the test as new. It will show up as unresolved over here. Even though it doesn't have a baseline to compare it to, it is going to be unresolved. And the reason that is important in some cases is because you might want to take a look at the screenshot first before saying, yes, this is acceptable. This is a good screenshot or a good baseline. I'm going to do a thumbs up and I'm going to save it as a baseline. So you can define that behavior. Default to automatically save the baseline or override that as well. But the next time when the test runs with the same combination of 5 parameters, in that case, it finds a corresponding baseline and it is going to compare against that, or rather with that.
Okay, interesting. But that means when you're changing your test or updating your test like we did before, then the first run will always fail then, because it will compare to maybe a different. If you, for example, had 3 tests, but you add a test somewhere in between, then it will always fail because he expects a different order and from the last run.
So in that case, it will show up something like this. I think this was the first time we ran that, right? Yeah. This was the first time we ran that. So this one, first one, second one had corresponding baselines. This one was different. Remember, I changed that instead of a window, I changed it to an element, right? And this was a new screenshot that was captured. I did not code it correctly right now when I ran the test because I was trying to show a different aspect of the behavior. But ideally, step number 3 would have been unresolved because that is a new step that has been added. And the step number 4, you see over here 4, this would have been a proper comparison. So only the one that you have added in between, that would have shown up as unresolved.
And just like the 4th one, like that will appear all the new tests or tests.
Correct.
Then you can see, okay, this one looks good. I want from now on use it as a baseline. Okay, pretty interesting.
Exactly. Right. So now if I come over here and say, yes, this looks good, I'm going to do a thumbs up. When I do a thumbs up and close this, you see now everything is passed. And it is passed, but I have not saved it yet. You see on the left hand side, it is unsaved, right? I need to save it explicitly for it to say that, yes, this is my new baseline now. If I do not save it and you run the test again, these changes have not been saved as part of the baseline. So it will not compare it correctly. It will give the same results as before.
Okay, thank you very much.
Sure. Any other questions?
I had a question about the driver. I use not a basic Selenium Chrome driver, but I use the driver agent of test project. I don't know if you heard from them.
Yeah. Yeah.
They create actually a shell above Selenium. Does this also work with the test project agent with those drivers?
It should work. I have not used test project directly, but test project is also based on Selenium WebDriver for web and Appium for native. So there might be some changes required. If it's already worked for you, then that's great, right? There's nothing required to be done. But if it doesn't work out of the box, there might be some small tweaks required to fit in this Applitools instantiation and teardown in the test project way of working.
Okay.
That's the only difference that would be required. Otherwise, it should be the same thing, because under the hoods, it is still WebDriver that they use.
Oh, great. Okay. I'll definitely give it a try.
Sure. Okay. Now let's talk about the algorithms, right? This is probably a good example. Yes. So now, if you see this, for whatever reason, I'm flipping between the screenshot and the baseline and the checkpoint for this particular screen, right? There is a significant difference in the two screens. And the layout algorithm is catching that as a difference that is found, because there is a significant difference over here. In fact, let's look at little different examples. So this is a good example. This is Facebook login page in different languages. Now, if I'm using the layout algorithm, I see there is only one difference that is highlighted over here, right? And that is because this particular text is coming out of the bounds of the username box probably, right? That's what it might be. That's why the layout is been reported as there is something wrong over here. However, if you use the strict algorithm, you would see everything that is different on the page is highlighted as a difference. So with the layout, it was able to figure out the difference of height of the page is also not a problem, but the difference, the problem is in some other place. But with the strict algorithm, whatever is different to the human eye, you are able to see that as a difference. And that's what is important to understand from our automation perspective as well. It is very easy, as you have seen, to integrate Applitools with your functional automation, but which algorithm to use is important. Should I be using a target window fully with strict algorithm here, or can I use layout? Versus, do I want to do this for a specific element compared to a specific table or the whole page? These are things that you as a test implementer would need to think about how to run these, how to integrate this. Whether your data is static or dynamic, that makes a big difference. How dynamic is the test? That also becomes a different aspect. Is the layout going to change completely for that matter, right? There are a lot of considerations you will need to have, which might depend on which type of environment you are running in as well. And accordingly, you will need to choose the algorithms. But once you have selected this correctly, then whatever the results are, you can get very accurate results out of that. There is one other aspect now that becomes very valuable when you have run the tests in this fashion. And again, I'll take this particular example. With root cause analysis, if it is enabled, you can click on the differences and you can find out what has really changed in the DOM and CSS, because of which that difference was seen on the screen. You can see there are significant differences for this particular element itself. It's not just the bounding box, there are other differences also that would be there for it. So you can look at this information, and the UI developers can make a lot of use out of this type of information to figure out why it has changed and what needs to be done to fix the problem. So root cause analysis becomes a very important aspect over here. So with this, I will again pause for a little bit. I want you to try running this test on your own. Change the URL maybe to your own product website or any other website that you want, and try these algorithms in your own way. Run the test, and let's see what type of differences you are able to find, or what type of results you are able to see. Okay, can we take a few minutes to try that out?
A question about how the eyes reaches a website. Is it reached from my local laptop, or is it from the servers of Applitools?
So the test is running on your machine. It is pointing to your Selenium test is pointing to demo.applitools.com. It could be google.com, Amazon, or whichever website you want, right? It could be your internal website as well, does not matter. But when you say eyes.check, at that point in time, it captures the DOM and CSS information, the screenshot from the browser using the driver that you have passed to it in eyes.open. It gets that information, and that is sent to the Applitools server. In this particular case, we are all using the Applitools public cloud server, which is hosted on the West Coast in the US. That's where that information goes. That is where the dashboard is. This dashboard is in the Applitools server in the public cloud. The comparisons would happen there, but the results again come back to your test execution on your local machine. So your test can still fail with meaningful information, what has happened.
Okay, so my question actually was, we have an internal the development website, or our instance is protected behind a firewall, I think. So it's not accessible from the internet. That's what I mean. So Applitools doesn't have to have access to that site. Doesn't have to be whitelisted. Only the local machine. Or okay, great.
Exactly. Yeah. Sorry, I misunderstood your question earlier. You are right. It's only the local machine where the test is running needs access to your internal environment, and this local machine also needs access to the Applitools server.
Okay, that's not a problem. Okay, great.
Sure. So let's take another minute and see what type of validations you are able to do. Okay, can we proceed? Were you able to run the tests on some other website?
Yes, it worked, but I just added or removed all the other tests and just let one still be able to run for my new website. But I still get 2 failed image comparisons from the old ones. How can you solve that?
Yeah, could you share your screen and we could see that?
Yes, let me see if I can do that. Like this, for example.
Yeah. Okay. So if you click on the right hand side and see the app name, also get that added into the details on the table. Do you see the table icon on the right hand side, the way I had shown? No, on the right side.
I don't understand that. Can you repeat that, please?
Yeah, so can you click on the table configuration option on the right hand side of the browser?
Yes.
Yes.
Okay.
And select app. Okay. Now what you see is the name of the application, name of the test, OS, browser, and viewport size is the same as what you had in the earlier case as well.
Mm-hmm.
Right? And that's why it is comparing it. Now, if you open up the first screenshot. So over here, this part is fine. Go to the next one. Oh, so the image itself was not captured over here. That's why it failed. So it is using the earlier
remove those tests. But for example, if I want to remove in the future a test from that's what I want to know how you can solve that.
So you would do a thumbs up instead and save the baseline that there is going to be no screenshot for it.
Same here, as I suppose.
Yeah. Yeah. And now you need to do a save after you close this. Now you need to do a save, correct. I think this should take care of it.
Wait, that's my mistake. I wanted to try it on Firefox as well, and I was
Sure.
playing with that thing a bit. That indeed did a trick.
Awesome. Okay, so whenever your product changes, right? So in this case, you are saying, I don't want an additional checkpoint, but in some cases, it might be the functionality has changed. So your test has got updated as well, right? And what you're seeing as captured on the screen is the right behavior. So you need to go and update the baseline to say, yes, this is acceptable. Next time onwards, this is what I want to do as validation.
Okay, great. I was expecting something like a button to delete the test, but it's just accepting an empty baseline. So, okay, understood.
Yeah. The other thing as well, right, is, shoot, I just lost my train of thought. It will come back to me. There was another point I wanted to make on that, but I'll get back to that. Okay, any other questions in the meantime? Okay, so now what I want to know you to do is look at this, the next class that is there, UFG code. And before running the test over here, add the same line that you had to add in the other case, right? Where you said eyes.setConfig or set API key. Sorry, it was config.set API key, and give it that API key that you have. So can we add the API key to this file as well and run this test? And as the test starts running, observe in the Applitools dashboard what you see. Anyone able to finish the test execution? Okay, so can anyone share what they see as differences? Bart, Alex, could you share what do you see as part of the execution when it happened for this new test now?
Well, I'll share my screen just a moment.
Great.
Let's see. So I see different tests for the separate OSs and browsers and everything, which is the main difference, I think, with the previous ones.
Exactly. And how many tests ran on your machine?
5 pieces, I suppose. I guess you can see it here in these ones, I guess.
No, but these are UI tests, right? How many times did the browser open and close?
Yeah, I didn't actually pay attention to that. To how many, but I can run it again, basically.
Well, none, because they're probably running that ultra fast grid, I suppose.
Exactly. Exactly. So we see that the browser has launched, and we know from the code in the after hook for the after method, we are closing the browser instance, right? So, yeah. But now the test completed as well. We are still getting the results back, but I don't see another browser window open up.
Yeah.
And that too, it was just Chrome that opened up right now. But in the results, if you go back to your dashboard for a minute, you see you've got the tests run on Firefox and Safari and Edge as well.
Yeah.
Right? And that's the power of the ultra-fast grid, because you are now able to do functional and visual validation at the cost of running the test just once.
Yeah.
And this is another big difference when it comes to scaling your test executions in the traditional approach as compared with the ultra-fast grid. In the traditional approach, if you wanted to run the test on all these different browsers and different viewport sizes as well, right? You see the viewport sizes are different for each of those. So if you had to do this in the traditional way, you would run the same test 5 times, each time telling which is the browser, what is the viewport size that I want to run on.
Yeah.
But now if you just click on each of the tests, so click on the first one and click on the next one. Okay. Yeah, do you notice a difference in the screen size?
Yeah.
Right.
Yeah.
So the way responsive design is implemented, right, is when the page is rendered in the browser, based on the viewport size, the page realigns itself based on whatever your CSS designing has been. So with this approach, what Applitools does is it captures the DOM and CSS information. And if you go to your code for a single minute in the test itself and go to the setup method.
Yeah.
Yeah. Go down. Oh, not this setup. This is a different one. The setup.
Oh, sorry, I'm with the. Yeah. Okay. Yeah. Yeah. Sorry. Yeah, this one right here. I had it there. Yeah.
Now there is also one additional method over here. This is the wrong code you're looking at. You should be looking at UFG code.
The UFG. Yeah. I'm sorry. Yeah.
Right. Now go to the setup method.
Yeah.
And now you see over here, we've added these additional lines in the configuration.
Yeah.
To say which browsers and device emulation as well that I want to use. So basically what Applitools does is when you do eyes.open, you have provided this configuration to Applitools, and whenever you say eyes.check or eyes.check window, it is going to capture the DOM and CSS information, ship it to the Applitools ultra-fast grid, where it is going to render the same page in all these browser combinations that you have specified, Once it renders it in those devices or those browsers in the viewport sizes you have specified, then it will do a visual validation and you get the results back to your test automatically at the end of it. So if you go through the console logs, right, at the in your IDE, you will see you are getting results of all the browser comparisons over here.
Yeah.
Right. So this is, I strongly feel I've never seen anything like this in the 20+ years that I've been in testing and test automation. This seamless scaling that happens. You are running the test just once. You might not even have Firefox or Edge or Safari on your laptop, right? You are still able to get the validations happening automatically. And this is running in CI as well. So if you have 100 tests that are automated with the ultra-fast grid, and you can specify as many combinations as you want over here based on your use case or what type of user data you have to say, this is the automation strategy that I need, right? You'll automatically get all that feedback to your test execution. Your test will fail just once, but it will have specific failures. Oh, this worked on all the browsers except Safari. And that is amazing feedback, right? Because functionally, all the browsers are now W3C compliant. So functionally, if it works in one browser, it will work in all the other browsers as well. But the rendering engines are still implemented by each browser on their own. And hence there can be some differences when it comes to rendering when you open the page in different browsers. And that's what you are really trying to validate. That's what Applitools is doing for you. Your functional validation is happening on your machine itself when the test ran, but the visual validation is coming from the ultra-fast grid based on that execution. Does it make sense?
Yeah, just a question about it. So in theory, in the CI/CD pipeline, you could have one headless test, and then the rest would be handled by the grid, basically.
Exactly.
Yeah.
Exactly. You could have just done this test headless on your own as well. So in fact, if you go all the way up in this code itself, in the before method, there's this get environment CI, right? I think line 20.
Oh yeah, right. I see.
Yeah. So just say return true over here instead of return boolean.parse. That will force it on in headless mode.
Yeah, okay, I see. Yeah.
Right.
Just again. Yeah, okay, yeah. But then now when I run it, it's just headless, basically.
Yeah, exactly.
Yeah.
Exactly.
Yeah, I can run it.
So this takes a huge burden away. If I could share my screen again while you're running the test.
Yep. There you go.
I'm going to switch back to the slides. I'm on the wrong slides. Okay. So I want to spend a little time talking about the ultra-fast grid, right? The traditional approach, as I mentioned, is we run the same test on each and every browser, each and every viewport size. Why? Because that's what we are used to doing from years ago. Though the browsers evolved, they got into the W3C spec came pretty recently, but the browsers have started conforming to it. So before the W3C spec, each browser had their own way of implementation. So that's why you needed to run the same test across each browser to make sure everything is working fine. But now with W3C, functionality, if it works in one, will work in the others. That is not a problem unless you hit across a very rare bug of sorts, right? But what is still different is the rendering aspect out of it. And that's where the ultra-fast grid really comes into picture, where you don't run the test on each and every combination, just run once and get validation results from all these cases. So now, why does this become really important? The approach becomes very seamless, right? What we did is on your own machine, you ran a test and you got the feedback from it. But what happens is when the test is running, your machine is busy. Now you cannot use your machine for doing other things. Yes, headless might work in various ways, but still your machine is busy at this point in time, right? And the challenge is to scale for the number of tests and the different set of browsers that you might want. So what you do, you set up an infrastructure in your environment, in your organization with different browsers, browser versions, and your tests are going to point to that and use that as a Selenium grid, for example, to point it to your application under test. So now you take the challenge away of your machine being busy, but now you are incurring the challenge of maintenance and efficiency. How do you manage the different browser versions which keep coming up every week, if not more frequently than that these days, right? So how do you keep up to date with those and maintain those in a correct, efficient fashion? That's the next set of challenge that you now run into. So what you do, you would outsource this lab, your internal lab, to external provider, external lab provider. Now what you are doing is maintenance overhead is gone, but now you are incurring the cost of slowness in execution because your test is going to go from your machine out to the public network to the cloud provider. Then the test will run, and from there the cloud provider is going to hit your environment, your internal dev environment. You need to now expose your internal dev environment to this solution for it to be able to interact with it, right? So it becomes slow, it becomes unstable because you're going out over the open internet. There could be a lot of fluctuations and delays that happen which cause your test to fail intermittently. And the security issues are there because now you need to allow the external browsers to talk to your internal environments. So you're exposing, opening up more and more of your network to the outside world. That's a big problem. And these security constraints are more challenging, right? It's not just inward network access. You might create VPN tunnels, but you don't really know who has access to the tunnels on the other side. That still could be a problem because it's a remote unmanaged VM and anyone could have access to that, right? And hence you could, they could get access to your internal network as well. Hence compliance issues become a big challenge as well. Now we already spoke about this one, right? Where the bugs are typically, if you encounter a bug in one browser, you will find it in all the other browsers as well. But the bugs themselves could be either a backend server backend bug, which means it is browser independent anyway. And if it is a UI related bug, then the bug functional issues seen in one browser will be seen in the others as well. The aspect that remains significant to each browser is still the visual defects. And that's where the ultra-fast grid becomes a very important solution in that way. And you can provide as many different types of browsers. In fact, we support latest plus last 2 versions of that. So Chrome 94 is released. We also will have support for 93 and 92. And our team takes care of maintaining the browser versions. All you would be doing in that case is, if I show it to you in code, it will be browser type is Chrome 1 version back or 2 versions back. You don't have to worry about what is the new version or if the version naming scheme is changing or whatever. You're just saying latest 1 version back and 2 versions back. And likewise for Firefox, likewise for Edge Chromium. Edge Chromium is just 1 version back. Safari is just Safari also we've got 2 versions, right? And the devices, there are a lot of devices that you could choose, Android, iOS, tablets, you could choose any of those. And this is emulation mode, so you could also emulate it in portrait or landscape as well. So that would also be possible. So just by specifying this configuration, you'll be able to scale your execution tremendously. So now whenever your test runs and you say eyes.check window, the DOM and CSS information is actually going to the ultra-fast grid where the rendering would happen. Rendering will be done with Applitools eyes and the results come back to your test machine. And this is part of the same connection that is going out. So all we need is from your internal environment or wherever the test is running rather, you just need to make sure there is an outbound connection open to the Applitools server. It's only an outbound connection that is required to the Applitools server, not an inbound connection. So from a security perspective as well, it becomes very reliable. And of course, you might have a lot of tests. So instead of running it in sequence, you could run the tests in parallel on your machine itself. And it would still work fine with Applitools from a scaling perspective. Okay, so this covers all the environments at the speed of running a single local test. It is much more robust and stable. You get full functional and visual coverage at scale. No security vulnerabilities. You do not need additional test data or consumption, and you are not loading your environment, your corporate network as well with all this scaling, because when the page is rendered in the ultra-fast grid, it is rendered like a static page. It is not coming back to your environment to access resources. Whatever is required to render the page is sent as part of the ISO check call to Applitools ultra-fast grid, where it will render the page and do the validation. And hence it costs much less for the value that you are able to get. The cost is very trivial compared to all that load that you would need to take. Okay, so this is what the ultra-fast grid is. I'll again pause over here to see if anyone has any questions or further thoughts around this.
Question about the browsers themselves. Are they emulated or virtual machines or?
So browsers are on virtual machines. It's a combination actually. Safari is there on actual Macs. The other browsers right now they are on Linux, but we are seeing how to expand that infrastructure as well. But again, the browsers on different operating systems does not really change because again they are W3C compliant, right? So the validations will still be similar. What really matters is the viewport sizes, if you really think about it. So any browser type with different viewport sizes, just to make sure everything is working fine. So long answer to your question, it's a combination, emulation as well as real.
What about the performance? And at the moment we use browser stack, but I'm not really happy with the performance I get there as in speed. So what's here with ultra fast grid? Is it really that ultra fast?
Yeah, so you have a working code as an example, right? What you could do is you could run this Selenium Applitools example, the single test that was there, run it and time each test with different types of browsers and viewport sizes. And if you have to do this across 5 browsers, what you need is 5 of those browsers should be installed on your machine. The drivers need to be there and then you run the test, right? So how much time does it take to run individual tests the traditional way, right? Versus you run it with ultra fast grid and how fast you get the feedback. So because you're not really running same test on each browser, speed is tremendously fast. If 100 tests take 1 hour to execute, 5 browser combinations would mean 500 tests are running, which essentially means at least 5 hours of execution, right? Not taking into account any flaky tests, reruns that might be required. So it's at least 5 hours of execution time to get the feedback. With ultra fast grid, 1 hour plus maybe 5 minutes or 7 minutes or 10 minutes worst case situation. So 1 hour, 10 minutes to get feedback of all the 500 validations.
Okay.
It becomes that fast.
And what if you are running your tests in parallel and maybe other customers are also running a lot of tests in parallel? Does it slow down the process?
No, it doesn't, because each account is has a concurrency limit, and it is our responsibility to make sure we give you the feedback in the agreed upon time. Our typical SLA for any comparison, average size page comparison, is around 200 milliseconds per screenshot. That is once the request reaches the Applitools server, right? Because before that, it is not in anyone's control, right? You're going through the internet, whether you're using the public cloud or the dedicated cloud instance, if that's what you would, the customer chooses to use. The network latencies, no one can really control in that sense. But once it reaches the Applitools server, processing time is about 200 milliseconds per checkpoint on an average.
Okay.
So from a scaling perspective, the traditional approach does not make sense anymore, in my opinion, right? Unless there are teams who are still building browser-specific widgets, not cross-browser compliant widgets, but browser-specific widgets, then you would definitely want to run those on each of the browser. So typical strategy, what we recommend, because it's a very drastic approach for teams to say, OK, I don't want to run on any other browsers, right? Because I'm using the ultra-fast grid. What we typically suggest is instead of running 100 tests on each of the browsers, identify the 5 tests, smoke tests of sort, and run only those on each of the browser, just so that you get the confidence, yes, everything is fine. But the rest of the 95 tests can be run on ultra-fast grid, and hence the feedback cycle becomes tremendously fast, and you get all the functional and validation visual issues caught in one place in one test execution cycle. So it's a strategy again, right? Depending on context of the product, you can choose what approach is going to work well for you. Does that help answer the question?
It does
Yes.
answer my question as well, yeah.
Okay. Any other questions? So there's one thing that I did not speak about, and that is accessibility. If you look at any page, if you have accessibility enabled, contrast advisor rather enabled, then what Applitools can do for you is, depending on your configuration, level AA or AAA, WCAG standard 2.0 or 2.1, Applitools can tell you if there are contrast validation issues on in your product. And this again works across web, mobile web, native apps, PDF documents, images, anything. So we see over here, I just selected accessibility on this particular screenshot checkpoint. I chose specific standard and levels, and we are seeing there are 35 violations over here. You hover over any of them and you will be able to see what is the actual contrast, what is expected out of it. And this is very important because from a contrast validation perspective, there is no tool that works seamlessly in automation across platforms. Applitools is the only one that works across platforms for you. And what you're seeing right now is from the dashboard, but in your test execution results, you would also see what is the accessibility status over here. You will be able to specify that. In your configuration, you would also see how you can specify at what configuration do you want to check for accessibility for contrast validation as your test executes. So automatically now your test can fail for multiple reasons. One, there is a functional issue in your product. Second, there is a visual validation issue in your product. Third, functional and visual is fine, but there are contrast issues in your product and your test can still fail over there. As part of a single test execution across any browser device combination running as part of CI, you will be able to get all these different validations. And that becomes a huge value add when it comes to increasing test coverage without writing any new line of code, because this configuration is a one-time activity. It's boilerplate activity, right? Before hook, after hook. So in your after hook, you would get the results and you could customize the results to in your existing reports, right? You could take these results and add it to your existing reports, enhance them to include visual and contrast validation issues as well. But once that is done, you don't need to touch that at all. Then all you're saying is I'm going to focus on writing a new test. In the test, how many different validations do I need to have and where do I need to add those validations? And those validations are visual validations. That's the only thing that is required. So your test is very basic navigations and actions you're doing on your product, and whenever required, you're going to do a visual validation on at relevant points. Does this sort of paint a picture about what are the different capabilities you will be able to use?
Yes, it does for me.
And does it also answer the question about browser stack versus ultra-fast grid? What kind of differentiation and value one each can provide?
Theoretically, yes, but practically I'll have to
of course
play a bit with both to compare and see it for myself. But I'm pretty much convinced it looks very nice.
Great. Yeah, that's always our recommendation, even when I work with our partners and customers in POCs, right? We know how good the tool is, but till the people using the tool don't see the value, it doesn't make sense to talk about the license. It's a licensed tool, right? So value is most important to us. It doesn't help us if anyone just purchases the license but does not use it. And we strongly believe in doing a very value-oriented POC to work with our customers, work with our partners to make sure their use cases can be solved in the best possible way. And then we talk about the licenses. And that's what you should also for sure do. Experiment with it, play around with it, reach out to me if you have any questions around that. And we can definitely make sure your questions are answered.
The current account we have, how much more we can play with it? Is that a few days or?
So the account is free forever, but the limit is how many validations you can do per month. Okay, so there is a limit of 100 checkpoints or 100 validations per month. So what I would recommend you do is use the ultra-fast grid, but do not use a lot of browsers that can immediately, almost in a couple of runs, will take use up the whole quota that you have assigned. But ultra-fast grid is possible, is available to you. All the features are available to you, except probably accessibility, root cause analysis that might not be available. But you will be able to use the algorithms, ultra-fast grid, see the scaling features, how it works out, and compare it as well.
Okay, awesome. Thank you.
Sure. And as I mentioned, if there is a POC that you are looking to do this evaluation for a particular POC, then do reach out to us and we can work with you and give you a POC license with enhanced capabilities and number of checkpoints. So that way you will be able to do a much more thorough POC. From a learning perspective, the free account works great.
Okay, I will keep that in mind.
Sure. Any other questions? I think we have covered most of the topics that we had listed. Just a quick thing from our logging perspective. Once your tests are set up, then you might want to disable logging. You can just comment it out and that takes care of it. The verbose logs that you see will not be there. So your test output is more focused on what you really want. You can set the stitch mode as CSS or scrolling, which will allow you to take screenshots in different ways. So you can experiment with that as well. You can take screenshots only what is visible in your screen or take a full page screenshot as well. And that also is there in the sample code. Just uncomment those lines. You will be able to play around with that as well. Full page screenshots. So yes, I think we've covered most of the things that I have promised we will be able to do.
Maybe one question. How does the reporting work in Applitools? Because now we've run a test, but what if we run 20 tests and we want to see how all these tests, if they are all passed or failed, like when you run them from a CI pipeline, what's possible in Applitools?
Correct. So there are multiple ways how we could do this. One is you get the link to the dashboard in your test execution. So you could just go to that link and then you would come to, let's say this was the link that was there in the dashboard, right? Sorry, in your test execution. You've come here, there is a summary view about how many tests have passed, failed, or being unresolved. What is the baseline status, how many tests were there, how many checkpoints were there in those tests, browsers, operating systems, devices, viewports, and so on, right? So you will be able to get a summary view from here in the dashboard about what is going on. You could also just share this link with others, and as long as they are added to the account, they will be able to see this dashboard. Applitools license is not based on per user cost, which a lot of tools have, unfortunately, which makes it a very exclusive or a very privileged way of working with the tool. Applitools believes in team collaboration, and everyone involved should contribute to the quality. So as long as they are added to the account, they will be able to see the dashboard and take decisions on it. You can also have view only accounts as well. But the best value that you will get is from the Applitools dashboard. That said, in your test execution output, you will have the test results object. So this test results object that we had here, the test results summary. So you could use this and parse this object to get relevant information about your test execution and add it to your existing reports. This is in the after hook, right? So you can add it to your existing reports as well.
Yeah. Okay.
In fact, you could also download screenshots that were captured during the test as part of it, especially when it is failing, and attach it to the reports. If you want, that could also be done.
Yeah. Okay. Thanks.
Sure.
Okay, so if there are no more questions, I think we are about out of our time frame. Voila. Thanks for your time, you too, also, Anand. It was very interesting, and